And you are correct, yes, it's now starting with a question and answer session. And I see that we have quite a lot of questions, but we have quite a lot of time as well. So let's get started. So I see that you can also read the question from your seat, which is quite convenient. I just read it quickly to the people. It's for you, Emily. In case of any catastrophic event, could it be possible to add a survival parachute in order not to suffer this kind of detailed safety assessment?
So the short answer to that is no, that's not meeting the objective of the requirement. The requirement is to prevent catastrophic events from a single failure. So the fact that what happens after a catastrophic event is not part of the requirement. So the failure that's catastrophic is it would prevent continued safe flight and landing. So the use of a parachute following a catastrophic event is not showing compliance.
CS27 requirements does not cover the battery system as an electric thrust. Will it be covered in the new AMC through the VTOL in terms of fuel system safety? I'm just wondering who can take this one. Please.
I can try a bit. So, no, it's not currently in the CS27, but since it's different to the fuel system, of course, most of the fuel system paragraphs will not apply to this, except so where it does apply is the 952, which I introduced, the fuel tank crashworthiness, is also then covering or written in a way that it covers the battery crashworthiness. I guess the rest of the battery system will be covered by the electrical experts, as long as you have a battery with your VTOL.
Take the next one as well.
The next one. Okay. Amazed not to see evocation about the hazards of battery explosive short circuits in the crash protection requirement as one paramount criteria of the study. Well, it will be addressed, but I have to look up how specifically I mentioned it in the AMC, but for sure it is, I have not explicitly mentioned in my presentation, but through the no post-crash fire, it implicitly also says, no, you should not have any battery thermal runaway, which could lead to explosion, to fire of the battery. So whatever happens after the crash, it should not endanger the survivability of the occupants.
So crashworthiness again. Will the EASA discuss the use of simulation, or is the test only being considered?
I think that's a generic question for structural substantiation. We accept analysis based on a validated model, so we will. I don't see in the near future and the future that you can do a certification purely by analysis. But if you have a validated FE model, which you validated through test, you can surely use this model in order, for example, to show compliance when you change anything in your structure and you have a validated model.
Still on you, Heiko, about the weight of 77 kilo for test dummy and if it's reflect today's society.
Probably it does not accurately reflect it, but I think that's a wider discussion which we will not start on the VTOL, because this is consistent through all the CSs we have, and I think if we want to touch this, I think that it must be done on a wider scale, covering everything from small aircraft up to large aircraft, rotorcraft. So we are not planning of touching this by introducing it now through the special condition VTOL.
Emily, how can we quantify structural failure as extremely improbable?
Yes, that's a very good question. I expect that's related to the Part B of the AMC. In this case, if it's not possible to do a quantitative analysis, we would have to look at a qualitative analysis to ensure that the design provisions are sufficient and agreed with EASA that we can be confident that the single failure leading to catastrophic failure is extremely improbable. So probably be qualitative in most cases. But it's very limited anyway, the use of Part B.
Anonymous question. Is there any requirements or special condition regarding icing on rotor blade or on the vehicle in order to avoid rotor lock, loss of thrust, or maneuverability? So I guess Regis.
Yes, indeed. There will be some icing requirements. There will be expressed. So for the distrust system, they will be expressed in these special conditions, EHPS, that I will present later on. And for the aircraft, I don't really know. I guess there might be some requirements if you are willing to certify your aircraft for icing conditions as well.
There's also the specific VTOL requirement 2415, which is talking about ice protection.
Emily, is the failure assessment for parts only, or are there guidelines and requirements on materials where structural parts are made from as well?
The requirement is a design requirement. There are also the structural requirements themselves, and we have a specific materials requirement in the VTOL special condition.
We have quite a lot of questions indeed on this.
I'll leave the microphone on then.
Edris, I guess it's for the part you presented on the FHA, oh no, Emily, sorry.
That's me again, yes.
FHA is required for primary structure parts, or is it required for secondary structure or all structure parts?
In theory, it's for all parts, but if your function of your part, the failure of the function of the part is not catastrophic, then your safety assessment finishes there. We're only looking at the catastrophic consequences. Of course, normally secondary structure is not load path and the failure is not catastrophic, but we also want to take into account what happens to the loss of a fairing or a cowling. If that could impact something which would lead to catastrophic consequences, then it has to be continued in the safety assessment.
For VTOL, with pitch change mechanism, is there any requirements or special condition to put blades on a feathered or another position to avoid loss of thrust and maneuverability? So for this one, I'm not sure if we can reply from EASA perspective, because it's a design choice.
So if it's related to the design requirement, if you have there's no specific requirement to have such a mechanism, but if you were to have such a mechanism that avoided the catastrophic consequences from the single failure, then that can be taken into account. But I don't think we have any specific design requirements.
As a compensating provision?
No, or not as as the safety assessment.
For the FHA, is this requiring to do it for every single structural part?
Yes, again, in theory, yes, it's for every structural part, but if they're grouped in functions, the loss of function is not catastrophic, then the safety assessment can end there, providing that the loss of it doesn't cause a catastrophic failure of another component.
Lightning strikes. So Jean-Christophe, would the EASA required to do tests for structural damage after lightning strikes, and then test residual strengths after strike for composites?
It was not the subject of this today symposium. I was covering only the indirect effect of lightning, so maybe my colleague of structure can answer. But, I have no idea, frankly speaking.
We still have in the structural durability requirement 2240 for enhanced category the damage tolerance analysis. So lightning strike and residual strength following lightning strike is traditionally part of the damage tolerance analysis if that is a threat in your threat assessment.
Heiko? Is there going to be a specific AMC related to crashworthiness for medevac operations with a stretcher litter?
I don't think that we will explicitly have an AMC for that. I mean, we have a bit now in the CS27 regarding litters that you have to comply to 561 to the static loads. You have to apply a factor of 1.33 of it. It does not have to comply to 562 to the dynamic seat test requirements. I think this would be taken similar for a VTOL, but I don't think that we, at least as a first go on our AMC, we will explicitly mention medevac equipment, whereas the litter is the only special thing on the medevac, at least regarding structure. The rest is installation within the cabin, and you have to ensure that any item of mass in the cabin is restrained to the 561 load. So I think the only topic which we could address in the AMC is to make sure that the requirement for the litters or berths are well understood.
Then we have two questions on structure. So what is the structure part within the lift thrust unit? And directly after this one, you can take what about drone strike on the windshield?
Okay, so that's a very good question about what is structure and what is system. We often have this discussion. It's sometimes a little bit of a grey area where the overlap is. Essentially, anything that carries the load path is definitely structure.
Just to complete, basically, I think it will depend on the design and the definition. What is the VTOL lift and thrust system? I would say if it's regarded when we consider bird strike, we try actually to avoid to make confusion in definition by setting a criteria like single birds 1 kilo has to be evaluated, multiple bird impact when you are considering redundancy. And at the end, you have actually integrated thrust lift system, you have control surface that are integrated to the engine. I would say what is not engine might be structure. About the next question, drone strike on windshield, it is not considered today. Clearly not. Basically, there is a working group on interaction between drones and manned aircraft. And in this working group, we are going to work on the possibility to make drone a bit more frangible so that basically the first that we're supposed to fail after an impact will be the drone and not the manned aircraft. So we cannot specifically address this point today, but next year in 2020, I think we'll have good elements to answer this question.
So I propose we take two last questions before going to the coffee break. So next question, it's why conventional takeoff and landing, CTOL, for VTOL is presented as a difference as compared to conventional rotorcrafts. I'm not sure I understand the question.
No, I mean, yes, so we have the typical VTOLs which are operated as the same kind of as a rotorcraft, vertical takeoff, vertical landing, and compared to that, we are also seeing designs which are primary or which also have a conventional like a standard CS-23 aircraft landing capability, which can choose either to do it vertically or to have a classical landing with the lift mainly coming from lift surfaces. And in that case, it is operated like a 23 aircraft with a higher forward velocity, and that's why we would impose also higher impact G forces on this kind of vehicles.
And the last question for the session, it's regarding the presentation on single failure for structure. So regarding 2250C, what is the reasoning for going to such extreme measures with respect to single failure criteria for structure?
That's another good question. So as I tried to highlight, unfortunately, with all the precautions we still have in CS27 and 29 with fatigue and damage tolerance and critical parts, we're still having catastrophic events in service due to single failures. And this really is thought of, the VTOL configuration with multi-lift thrust is really considered a possibility for us to remove these kind of failures by design, because you can have segregation and you can have redundancy. So we're taking it as an opportunity to prevent these in-service events that unfortunately we're still having.
Then I can just say thank you to you for all these questions, and thank you to the presenter for their presentation and all the answers you have provided. I hope you enjoyed. The first time EASA is going public about this level of detail on how to comply with the special condition VTOL that was published over the summer. As you can see, we are playing with some new concepts, and this presentation of today is basically the start of a discussion rather than the concluding of one. So all the documents will be published early next year for comments.